Contributor Weekly Meeting. We have a couple of items for the agenda today. Please feel free to add any new items that you want to bring up to the meeting notes and agenda document. Probably quickly share it on the chat window right here. Presentation of the design proposal for orchestrating Cstor pools and volumes. This is going to be at probably at somewhere between high level and getting into a little bit of details. The slides have been prepared by pulling in the details that are already part of the design proposals that are in the pull requests mentioned in this agenda slide. So we have two design proposals. One is just to orchestrate the Cstor engine, basically creating OpenEBS volumes with Cstor engine. And then how do we create snapshots and clones on OpenEBS volumes using Cstor engine, right? To kind of understand this concept, I'll give a quick recap or into the Jiva volumes and then some of the Kubernetes concepts that we use to make that happen. Please stop me at any slide. There's some assumption that I've made here with respect to the knowledge of Kubernetes. Feel free to stop me and then ask any questions in between. Okay. So I'll get started with the way the OpenEBS volumes are created using Jiva as of today. Typically, a DevOps admin comes in and from on his Kubernetes node, if there are any disks or any additional disks attached to that node, you will have to format those disks and mount it into a location using ext4 file system. Let's say he mounts it in mount OpenEBS, right? And then he creates a storage pool object and by specifying that mount path that he created. And one of the requirement or the constraint is this path of the storage pool has to be available on all the nodes with the 0.5 release. Okay. The next step for him is to create storage classes, and in the storage classes, along with specifying few parameters like how many replicas, what is the default capacity, etc., he will also have to mention the storage pool object that he has created as a parameter. That's pretty much it. So the DevOps admin just sets it up, and then now comes a developer. They can start running stateful apps that use a PVC using a one of the storage classes that the DevOps admin has created, and that will trigger the dynamic provisioner to create a OpenEBS volume. So now what is this dynamic provisioner, how it works? Let's just get into a little bit of details there. So before understanding dynamic provisioner, it's very important to understand the core principles under which the Kubernetes platform itself is defined. And this pattern kind of is used pretty much everywhere in the Kubernetes. So you can kind of break down all the features of the Kubernetes into this core principle or the core pattern, right? So everything in Kubernetes is a resource. So resource is an object that's stored in the etcd. And the controller is either a binary or a container that basically looks at these resources and performs certain actions, right? So a resource typically has something called as a current state of world. So it's basically some attributes that define what is the current state. And the same attribute or a different attributes can specify what is the desired state that resource has to move to. Right. Now, this desired state could be something that admin or the user specifies, basically saying I want a capacity of certain amount. That's a desired state, right? Or I want so many replicas. That's a desired state. And the controller looks at the current state and makes sure that the resource moves from the current state to the desired state. And as part of moving this, it could be different tasks that it can perform. Some could be just configuration tasks or updating back the resource object with certain attributes, or it could be also creating other resources. So when we say other resources, for example, it could be the resource could be a deployment that the user has loaded into the Kubernetes using kubectl apply deployment. That will result in a controller that is watching this deployment AML file to create required pods. And similarly, whenever a PVC object is created, some controller is looking for those PVC objects and trying to create a PV object. Since we are interested in PVC, let's look at what happens when a PVC is created. So PVC is a resource object that's stored in the etcd. It is watched by a controller called as a dynamic provisioner, and the dynamic provisioner could be either an entry or from out of tree, basically by using the external storage provisioners. So now this PVC will have an attribute called as bound, which basically tells you what is the current state. So if it is none, that means there's no PV that has been created for this particular PVC. So dynamic provisioner will be looking at PVCs. Of course, I've not mentioned the storage class here, but it will be looking at the storage class and seeing if it has to do any action. And it will look at bound equal to none, and it will trigger an workflow where it can interact with storage control plane to create the actual volume on it, and then create a PV object and associate it. So it updates the bound equal to PV. That means the current state has moved to the desired state of having the PV object created. So now this is an important concept. So it's worth spending one more slide on this one. So everything is a resource and everything is a controller. If you look at to kind of drive home this particular pattern, let's take the example of a pod. Pod is again a resource, and there could be one or more controllers that are actually operating on that particular resource. So in case of pod, kube scheduler is one of the controller that is looking at new pods that are getting created or the objects that are getting created, and it will basically look at the scheduling information of the pod, basically the node assignment, and it will be obviously none when it gets created, and a scheduler makes some intelligent checks to assign the node where the pod has to run. Right, that's the job of the kube scheduler. So there's also a kubelet that keeps watching for the pod objects, and it will wait till a particular pod is assigned to the node where the kubelet is running. And as soon as the kube scheduler updates the pod object with the node, kubelet takes it and starts the containers on the node. All right, so this is the default resource object, or like Kubernetes native resource object with Kubernetes native controllers. I've specifically picked up kube scheduler and kubelet. If you look at it, kubelet is running as a binary or a container. Kube scheduler is also a kind of a controller, or it could be run as a binary. Right? All right, so the next example is about a PV. If it is an in-tree volume, then typically kubelet is the watcher for that PV, and that triggers the dynamic provisioner. But if it is an external storage like OpenEBS, so we have a custom controller defined, right? So just using the same constructs that are used by kubelet and kube scheduler to implement the controller logic, the OpenEBS provisioner is also implemented using the same API. Right? It basically extends the watcher of the objects and some interfaces to implement the actions when an object gets added, deleted, or updated. Right? So custom controllers have been around for some time, and with the 1.7.5 and all, even the objects could be extended using custom resource definitions. So in the example or the workflow that I mentioned before, storage pool is actually a custom resource. Now, the custom resources can be just information objects that are being stored, and basically via the kubectl API you can query it and then just use that information. Or you could actually write custom controllers that operate or that basically trigger a workflow based on the objects that are getting created. Trying to see if the chat window here. Okay. Any questions so far? All right. So the
Hey, Kiran, Amit here. Can you just repeat about the CSW?
okay, it's a concept. So it's basically current state of world, right? Every resource will have certain attributes that define what is its current state. Actually, this current state of world and desired state of world are used in this concept of a controller, as well as in some other concept where we issue a kubectl apply command, for example, right? So instead of, I'm not getting into the apply right now. So every resource has something called as a current state of world, which in case of a PVC, the bound parameter can be treated as an attribute that defines the current state of world. And the state that we want to know is whether a particular PVC has a PV object created or not, right? And the current state of world and desired state of world are the interpretations of the controller itself. Okay. For example, if you take the pod, right, the node assignment is used as a current state of world by the kube scheduler to determine whether a particular node has been assigned or not, and whether it has to do something depending on the state of that particular attribute. And kubelet also uses the same attribute, but it also checks whether a pod has been created or not.
Okay, fine.
All right. So just putting it together, these concepts, just giving a recap of how the Jiva volume is getting created. So the initial steps are with respect to the setting up of OpenEBS, which involves formatting and mounting the additional disks that are there in the Kubernetes cluster. So in this case, let's say we are putting it is in /mnt/OpenEBS. And once that operation is done, you have to go and create a storage pool custom resource object and place it in the Kubernetes etcd, right? And then you go and modify the storage classes, or like create new storage classes that will point to the storage pool for storing the data. Now a developer comes in and they can launch their application pods or stateful pods. And let's say that pod has a configuration to use OpenEBS. By OpenEBS, I mean they're specifying a PVC with a storage class pointing to OpenEBS, right? At this point, the dynamic provisioner kicks in as soon as the PVC object is created. And since OpenEBS is a container attached storage, it will start creating volume containers. So it will actually first start with creating a controller pod, which is basically an iSCSI target, and then a set of replicas. Depending on the policies, there could be 1, 2, or more of them. And the controller or the iSCSI target will have a service associated with it, from which you take the IP address and pass it on to the replicas so that they can kind of connect to the controller. And then the replicas are also configured to use a certain path in the /mnt/OpenEBS. So the OpenEBS provisioner's job is to create all these objects, the service, the deployment, the replicas, etc., and then create a PV object. That's a fifth step, right? And as soon as the PV is created, it's the job of the kubelet to kind of attach it to the node where the pod is running, and then give it to the pod. And after that, the stateful workloads are started. Okay. So I wanted to more focus on the objects that we are creating as part of this workflow. So for the pool itself, we are just creating a storage pool CR. Nobody is watching it. It's more like information that we store in the etcd that can get utilized while scheduling the replica volumes. Right? And for Jiva controller itself, a service is created and a deployment is created, and the deployment contains 2 pods. One is the Jiva pod, which is the iSCSI target, and also one is an exporter sidecar associated with that particular Jiva iSCSI target that pulls in the metrics in terms of the IO ops usage or the capacity usage, and Prometheus or any other monitoring tool can query that. Okay, and the volume replica is nothing but a deployment. And one thing I missed to mention is that replica also has Jiva container, and it has certain volume mounts that are coming from the MND OpenEBS. All right. So what's the change that we are bringing in when we are talking about Cstor, right? So the first thing is we had this step of manually formatting the disks and creating a path and using that path. So the first change that you will observe with Cstor is there's a node disk manager that runs on all the Kubernetes nodes that's used to manage the disks attached to a node. We talked about the design proposal in the last week's meeting, and Cstor is going to use that node disk manager functionality. And instead of creating a storage pool, the admin can create a storage pool claim, which will say, I want to use a certain type of disks that have been already discovered by node disk manager and create a storage pool, right? And there will be controllers now that will be watching the storage pool claim and creating the required storage pool, right? The third step remains the same. It's basically creating the storage class with certain parameters and associating the storage pool claim that we have just created as the pool. And the developer workflow also remains the same, no change there. They create a stateful app that uses a PVC pointing to the above storage class, and then that results in a dynamic provisioner, which in this case is an OpenEBS dynamic provisioner, creating a PV, and the stateful apps get loaded on the Cstor volume. Okay.
Hey, Kiran, there's a question here. So, like SPC and SP, these are the two resources, right? And node disk manager is the controller. Is it the same theory that you had shown earlier in the slides?
Yes, that's correct.
Yeah. Okay, thank you.
Just playing that step by step, what happens when a Cstor volume is created. So as part of the setup, the admin does not have to do this manual step of formatting and mounting. Rather than he just runs the node disk manager, and this node disk manager runs with the upcoming version. It will run as part of the OpenEBS operator itself, right? Today we have API server and provisioner, but that will also include node disk manager. And the admin creates an SPC object, or he loads that, and then that will result in creating the storage pools. So when we talk about storage pools, we actually launch a Cstor pool container that's making use of the disks that the admin specifies that satisfy the criteria. And he could also specify how many Cstor pools have to be created. So let's say in this case, I have 2 nodes to show in this deck, so 2 pools are created, right? And then the storage class object has to be created to use that particular storage pool. And the developer workflow also remains the same as far as the launching of the pod goes. Now, when the OpenEBS dynamic provisioner sees that it is a Cstor based volume, it goes and creates the volume controller similar to the previous one, an iSCSI target with some changes. We'll talk about these changes in the next slide. And for creating the volume, earlier we were launching the replica pods. So instead of that, what we do now is we create logical volumes on the Cstor pool that's already created, right? So there is no separate container launched, but an object that is created, which is a logical volume sitting on the Cstor pool, right? And depending on the replica configuration, these logical volumes could be coming from different Cstor pools, and they will be connecting to the target just like before, and a PV object will be created for them, right? Any high-level questions at this point?
Yes, Kiran. So we are talking about the Cstor, and then we are talking about the Cstor's pool. So is this, will the Cstor pool be created as a result of the SP, the storage pool?
That's correct.
Okay. And what kind of disks does this Cstor pool expect? Any special stuff here?
Okay, so as of today, these are going to be block disks that are required for Cstor pool. So for example, node disk manager will discover all the attached disks. So I have tested this with Google persistent disks on Google Cloud, right? So they get mounted in /dev as SDB, SDD, etc. Right? Those disks will be labeled as persistent disks or block disks and put it into the database, and SPC will say I want block disks. Right?
Kiran,
yeah.
Quick question. What's the minimum number of replicas that are suggested for production?
Okay. For requiring, if there's a need for high availability, then minimum is 3 replicas.
Okay.
Okay. To add to that question, like when we actually have a number of replicas, that in turn means each of these replicas will be on dedicated nodes, right? The separate Kubernetes nodes, right?
That's correct.
Then does it mean that the disks should be homogeneous in nature across the nodes? Yeah.
So we could go with that assumption, but that requirement, but the Cstor pool can be created on any disks that are available. For example, like the storage pool claim is very generic in terms of requirements. It talks in terms of I want certain capacity, I want certain IOPS, that kind of parameters, and it could specify the type of the disks as well. But let's say like on one node I have a 100 GB disk, whereas on the other node I have a 200 GB disk. That's okay, right? As long as we meet the minimum criteria defined by the storage pool claim, it can meet use of any type of disks that are available. Yeah, to answer that question,
okay.
I'm not putting, or like, in the design, we have not included the homogeneous type of disks as a hard requirement.
Okay.
Also, these example slides, these are very informative. It may be a good idea to include a third node as well, just to show that the replicas are always thought of as 3, so that the users are, driven to that assumption. Just the feedback.
Good point, Mark. We'll do that.
So, okay, Kiran, so here, what I'm missing here is where is the node manager, the controller we were talking about, where does it come into play in this life cycle of creation of the volumes?
Okay, super. So let me just back up. So what I have not done in this slide, probably what I should do is I've not included the control plane components, like for example, kubelet or the dynamic provisioner pods, etc. in these diagrams. As part of the installation, as part of setting up of OpenEBS, Node Disk Manager will already be running on all the Kubernetes nodes, or you could actually say that some nodes are specific or designated as storage nodes. So Node Disk Manager daemon set only has to run on those nodes. So it will be running on only those specific nodes where additional disks are available or additional disks can be provisioned. Right. So Node Disk Manager is already running at this step, right? At the step 1, and when we create a SPC to SPC object, SPC is the object that the admin puts into the Kubernetes environment using kubectl apply SPC object. At that time, the disk manager is already watching for these SPC objects. And okay, one step I also missed again now is Node Disk Manager, as soon as it runs on a node, it discovers the disks that are already attached and puts them as custom resources in the etcd as disk objects. Okay, and when the administrator comes and creates a SPC, it will basically query for those disk objects that are already there and determine how the storage pools have to be created, which nodes have to be used for creating the storage pools, etc. And the storage pools are created. Okay, all this happens as part of the DevOps admin setup process.
Kiran, just had a question.
Sure, Karthik.
Okay. So I think generally the controllers which are monitoring the resources also try to bring it to the DSW state, the desired state of world, whenever it is not met post scheduling. For example, let's say you have a kubelet which is overseeing the pod, and there is some container crash in the pod is basically brought back up by kubelet. So will the node disk manager also serve a similar function with respect to disk, which are the objects which will be managed by node disk manager?
That's correct. So in this case, let's say we have to get into those specifics in the design document as well. So the desired state could be an object for that particular thing is created or not, and whether it is used by any storage pool, for example. If it is used by storage pool, then start monitoring this for faults that are happening on that particular disk, etc. Or monitor the metrics on that particular disk. Right? So node disk manager will be doing all that stuff. And primary responsibility will be also to mark the status of the disk, whether it is good, bad, offline, online, that kind of stuff.
Okay. Okay, thanks.
All right. So just like how we kind of laid out what are the different objects created whenever a Cstor volume is created. So when a Cstor pool is created, which is as part of the setup operation, a storage pool custom resource is created, and a storage Cstor pool config custom resource is also created. And this Cstor pool config custom resource is passed as an argument to the Cstor pool deployment, or actually it's, the ID of it is passed. And the Cstor pool deployment will have 3 containers running in it. The core functionality is provided by the Cstor pool itself. And Cstor pool management is a sidecar, which is the one that implements the controller for watching the Cstor pool config objects, right? And or basically the updates on it, etc. And the Cstor pool management is the one that actually takes the ID of the Cstor pool config. So it's only going to watch its own Cstor pool config. And then an exporter is also added here to monitor the metrics at the pool level. Okay. So for the volume controller, it's going to be a Cstor service that kind of defines the IP address to access, etc. And there is going to be a deployment which contains primarily the iSCSI target. And I think you should name this as Cstor volume. It's not controller. And then a Cstor volume management, which is again a sidecar that's that acts as both an API server as well as a CRD watcher for updating the configuration of the iSCSI target itself. The iSCSI target configuration is now passed as a Cstor volume config custom resource object. Right? And the Cstor volume replica is, since it's just a logical object, there is no container associated with it. It's a custom resource, Cstor volume replica. And that one is watched also by Cstor pool management. And the control plane makes sure that volume replicas have the pool GUID where that particular logical object has to be created. So the Cstor pool's pool management will pick it up and create the logical volume on the pool. Okay. So now let's say like a Cstor volume is already created. Now let's look at what happens when the developer wants to take a snapshot on that particular volume, right? So we make use of the volume snapshots feature that's come in Kubernetes. So a developer creates a volume snapshot object specifying the PVC for which the snapshot has to be taken. At this point, the snapshot provisioner picks up that information and it invokes the snapshot API that's running in the volume management sidecar in the volume controller pod, right? And the controller that's running there is going to pause the IOs for the millisecond or whatever, or less than that, and then it goes and creates the snapshots on all the replicas that are associated with that particular volume. Okay. Now, once a snapshot is created, the use of it is either to promote it for recovery purposes or create a cloned volume. Both of them are mounting of a snapshot and the creating of a clone are achieved by the same workflow. Again, we use the same constructs that are defined in the snapshot Kubernetes snapshot API workflow. So to promote, the developer will have to create a PVC object, and this PVC object, instead of specifying the storage class as some of the OpenEBS storage class, it will be specifying a snapshot provisioner and the name of the snapshot from which the volume has to be created, right? And this will result in the control plane creating a new volume. So this time it will actually create a cloned iSCSI target, and it will create a Cstor volume replicas with the information from the snapshot from which those replicas have to be created. So the cool thing with Cstor is this is a logical object which is referring to a snapshot. So there's no extra space that is required for creating that cloned volume. It basically just points to the snapshot on the storage pool, right? And the admin can specify in this PVC from snap whether he wants to mount it as a read-write or a read-only. And if it is a read-write, it's the additional data that is coming in or the modifications that are coming in or the only thing that will occupy the space on the Cstor pool. All right. I think that's what I had in terms of the slides for today. So as soon as that particular clone object is created, a clone PV is created, which can be used for mounting into another pod, etc.
Question, Kiran. Does Kubernetes provide a way to schedule the snapshots in periodic intervals, or is it outside the scope of the API that's provided?
Correct. The default API doesn't provide it, but there have been suggestions on using another controller, basically that extends the cron job controller. That's another construct that is available that could be used to schedule the snapshots.
Is Node Disk Manager or any other OpenEBS components natively bring this capability of scheduling snapshots? Because that's pretty common in most of the enterprise deployments.
Right, Mo. I think that so the current thought process is we can have a volume policy associated with a certain storage class that can say I want to take these periodic snapshots, right? So at that point, after creating the volume, we can also launch a cron job with the specified schedule, and that job basically Kubernetes takes care of triggering that job based on the schedule, and then that could actually result in invoking the create snapshot workflow.
When you say volume policy, that's mentioned in the PVC parameters, right? Volume policy.
That's correct. Yes.
Hi, Kiran. This is Ganesh.
Hi, Ganesh.
I have a question. Like, is this the reason? because of intermittent periodic snapshot, you decided to go for gRPC, REST API instead of CRD?
Okay, so the question is, what's the reasoning behind going with the CRD for creating volumes, deleting volumes versus going with the API?
Yes.
Okay. So we wanted to keep this as disjoint as possible, the volume creation and deletion processes. For example, if it is tied into an API server, there could be a lot of conditions that come in, especially because this is kind of put in on different nodes and different controllers are managing it. Coordinating that will be a complex logic for the control plane. If we have it as a resource object, then as soon as that particular node comes up, if it was not online during the process of creation, it can take the corrective actions. Right? So that's the beauty of that custom resources objects having the current state and the desired state.
Yes.
So the control plane just says, this is the desired state that I want to go to, and the controllers can automatically make sure it happens. Right, but okay, so you also raise a good point. So this is the intent behind using the CRDs, but then we also experimented or explored, can we use the CRDs for taking the snapshot also, right? But for the snapshot though, it's a very time sensitive operation. It either just happens in that instant or it doesn't, right? It cannot be triggered using a reconciliation logic. That's what is the word used for going from current state to desired state. Reconciliation logic does not have a time frame associated with it, but snapshot has a time limit, right? It has to be in that instant. That's why the API service was introduced onto this controller so that the snapshot flow can be controlled very tightly at that point.
Okay, so it is the Maya which will give request to the sidecar for making the snapshot, right?
That's correct.
Okay. Okay, thank you.
Yeah. So I've been just looking at some of the comments. I think some useful comments are coming in specifying exactly what slides are a bit complex to understand, etc. That feedback is welcome. Please, put in as a documentation note or in the chat. I'll try to work on it and try to simplify it as much as possible.
Kiran, one more question. Like this, able to hear me?
Yeah, I can hear you, Ajay.
Yeah, okay. So the Cstor pool will be specific to a node, right? So how do we associate, like it's like the association of the node to a pool, and that kind of configuration will be set in where will be set in PV or SPC?
Okay, so the Cstor itself will be pinned to a given node using the Cstor's deployment file, and this information also will be in all the resource objects. So the way to do that is again by using one Kubernetes option, which says, like, in the node selector you can specify which node it has to be running on, right?
Okay, so that has to be done and the creation part itself when Cstor is done, right?
That's correct.
And whether that can be migrated to somewhere else if the disks are available, or
I think yes, that flow I have not yet considered in the current design. But that is definitely something that's possible.
sure, thanks.
So also I request you all to some of these comments with respect to the design, right? Or like the features that you want to see. to be updated in the GitHub PRs that are mentioned for the design. I've not closed these design PRs till we get the initial implementation done, and Ganesh has been helping with implementing these things. So please go and comment on these PRs with any features that you want to see or any more workflows that you want to add, etc. All right, if there are no questions, I will hand it off to Uday. Thank you, everyone.
Thanks, Karan. Thanks for the excellent session. I'm just going to share my screen now. Am I audible to everyone?
Yes, Uday.
Yeah, sure. So, is my screen visible?
Yeah.
Okay.
Yes.
So, hello everyone. This is Uday. I work as a DevOps engineer at OpenEBS, and I basically automate stuff. So today, for the past couple of community meetings, what OpenEBS has been doing is, along with the features that OpenEBS is releasing, we are also maybe for the last 10-15 minutes of the call, we are sharing some pro tips that OpenEBS will share with the community, which OpenEBS thinks are best practices that they are doing at the organization. So you would have already seen in the last two sessions where we had shared about using Stern as a logging framework. So you don't have to depend on Fluent, DEFK, and other things. A simple logging mechanism using Stern can be done. So one more thing, in today's session, I'll be talking about how you can bring up a Kubernetes cluster by just having some Vagrant VMs. So let me just get started with it. I'm going to actually bring up a Kubernetes cluster, which will be running Kubernetes 1.9.4. So the cluster is actually bootstrapped using KubeADM, which is one of the most popular tools that is currently being used for bringing up your Kubernetes clusters. The advantage of using KubeADM is you can bring up a multi-node cluster, which we have available VMs, unlike Minikube where it just runs on one node. And the advantage of using Vagrant along with KubeADM is that you can easily tear down and bring back up your cluster anytime you want. And the thing is, automation of this KubeADM allows you to bring up specific versions of Kubernetes clusters on demand. So let me quickly go to the demo. So the prerequisites for this demo are quite simple. What you will need is VirtualBox, Vagrant, and Git installed in your Linux distros. And basically, you just have to clone our OpenEBS GitHub repo and browse to a location called K8s libvagrant. We have already created a script called createVagrantBox.sh, which automates most of the process where it downloads the relevant binaries required for relevant binaries such as kubeadm, kubelet, kubectl, and the Kubernetes CNI libraries. So it downloads these files and installs them into the Vagrant VMs and brings up a cluster of Kubernetes. Sorry. So what does the script do? So basically the script takes a couple of parameters where you'll specify what Kubernetes version you want and what Linux distribution you want the script to create basically. So currently we are supporting Ubuntu and CentOS. Basically, if you say that you want, say you want Kubernetes version 1.9.4 with on a Ubuntu distro, so this script is going to go ahead and create a Vagrant box for you. And once the Vagrant box is created, at the end of it, it's going to bring up a cluster of one master and two nodes. So it's, I mean, it's very simple actually. I mean, you don't have to rely on GKE or AWS. I mean, in cases where you want to test out new Kubernetes versions, you don't have to mess up with your existing environment. You can just go ahead and use the script and bring up a 3-node cluster and play around with it. Let me quickly take you to my terminal. So what happens once the script is run, we're actually creating a Vagrant box, and that box is uploaded into Vagrant Cloud. And just a moment. So once the script is run, it actually creates a Vagrant box and a Vagrant file that is actually required to load the box and run it. For example, if you say it can have a Vagrant file which has been specifically generated for 1.8.8. So when you run this Vagrant file, it's going to download the box that has been uploaded into Vagrant Cloud, bring up a Kubernetes master. So you can define the parameters that are required. Basically, we have some environment variables where you specify what is the number of Kubernetes masters that you require, what are the number of Kubernetes minion nodes that you require. So once this is done, the box is downloaded. I mean, okay. So if you look at this, we had created a couple of boxes for CentOS as well as Ubuntu. And once you run the Vagrant file, these boxes are downloaded. And let me quickly run one of the boxes and show you. See that I have Vagrant file which is going to bring a 1.9.4 cluster of Kubernetes. I've configured it to bring up one master and two minion nodes. Currently the VMs are not created. I have the box already downloaded on my machine. So when I just go ahead and do Vagrant up, this is going to bring up a 3-node cluster consisting of one master and two minion nodes, and it will be on Ubuntu distro.
Hi Uday, Amit here.
Yeah.
While this is running, I have got a couple of questions.
Right.
Will this setup have RBAC enabled, or will it be a separate manual stuff?
We are actually using KubeADM. So by default, KubeADM will have RBAC enabled.
Okay, all right. And will this installation have OpenEBS installed by default?
No, this is basically allow you to bring up any specific Kubernetes class version that you want. So when you say create Vagrant box, you specify what Kubernetes version you want the box to be configured with. So it will configure that box with that specific Kubernetes version, and it will allow you to just spin up a Kubernetes cluster. Open installation of OpenEBS has to be done once the master is up, and you have to do a Helm installation or kubectl apply of the OpenEBS operator.
Okay, all right. And is this script the same to, so if I want to bring up OpenShift installations, is there any similar script via Vagrant that has been created? Or
it hasn't been yet, but it
okay,
should be available in maybe a week's time.
All right, thank you.
Yeah.
Right.
Yeah.
So let's say that I want some configurable parameters for my cluster. Let's say I want it to be a multi-node cluster, maybe 3 nodes or 4 nodes. So is there an option in our create script where we can specify that?
Sorry, I couldn't get the last part. What was it?
Let's say I would like to create a 3-node or a 4-node cluster.
Right.
So is there an option that we have in our create Vagrant box script that can be provided?
Create a Vagrant box will actually just create a box for you which has Kubernetes packaged in it. So the number of nodes that you want to bring up has to be configured in the Vagrant file. So the create Vagrant box will create a box as well as a Vagrant file for you. So by default, the number of nodes that have been specified. So if you, is this screen audible to you now, the terminal?
Yeah, I can see that.
So we have a section where you specify what is the number of Kubernetes masters that you want, what is the RAM that you want to provide for that node, what is the number of CPUs that you want to provide. So basically you configure it here and then just do Vagrant up. So based on what is configured here, it's going to bring up the number of nodes. So for my case, I have configured it to bring 1 for Kubernetes master and 2 for nodes. That's why I'm getting a 3-node cluster where 1 is master and other 2 are going to be minion nodes.
Okay, thank you.
Hey Uday, Amit here. So with these installations, can I set or configure kubelet in a container?
No, Amit.
Okay.
Kubernetes is going to run as a service only in this. I mean, if mostly what I've seen is CoreOS Vagrant boxes, so we'll have kubelet running in it. But as far as Ubuntu and CentOS distributions are considered, I've seen them running as a service only.
Okay. So recently our users have been using some of those platforms where kubelet comes up as a container.
Right.
So that was the reason I was asking if you are able to recreate the same step using this Vagrant setup. Probably will be able to help them out easily.
Sure, Amit. I mean, I can give it a try. What actually people do is okay, I forgot the name of the image. So Kubernetes has a image where you can make kubelet run inside the container of that image. So I think we'll have to try something similar to it. Maybe after this session, I'll just raise a issue for that and take it forward.
Oh yeah, thanks.
Yeah. So Having some trouble switching to the terminal. Okay, so the Vagrant up is still bringing up the minions. In the meantime, we can. I just saw that the master was up. We can just do a SSH into the master and look at what has been created. So basically, you run Vagrant SSH and log into the master. I'm just gonna run kubectl get nodes. So the master is up, but the first minion is still coming up. That's why the status is still not ready. Let me just put a watch. And as you can see, we are running Kubernetes 1.9.4, which was released only 2 weeks back. The first minion is up, so the state has been changed ready. In the meantime, and does someone have any questions? Maybe I can just answer them.
I think a follow-up question to what we had earlier about running the kubelet in a container. I think there were some efforts in getting the Azure, the Kubernetes cluster. Anybody on this call has a status update on that one?
Not yet, Karan. I mean, I think we will be trying it out today, and maybe by end of day we'll have some update for it.
Is there any minimum system requirements for this Vagrant setup to come up on the laptop?
I would recommend at least 8 GB of RAM. That would be sufficient to bring up a 3-node cluster. A little less than that, I think you'll have some slowness issues in the laptop. The thing is, at least you're recommended to assign at least 2 gigs of RAM for each node. And if you have a 8 GB laptop, I think it'll be good.
I guess we would require 4, 3 nodes and 1 master. So that we can test out most of the HA kind of scenarios.
Right.
Yeah.
I think the recent laptops, I think. Right.
Yep. And for that, probably more than 8 gig RAM would be helpful.
Right. I think for OpenEBS, it will be better to have higher RAM. But if you just want to try out a Kubernetes cluster, I think 8 gig might suffice. So the nodes are up. So let me just check. Okay. So we have a cluster now running. So we have a Cube API server controller. We are using Cube Router as a CNI plugin for this particular cluster. So you can use any CNI plugin. Weave and Calico are some popular CNI plugins. Cube Router is something new, so we just wanted to try it out, and it looks to be working fine for us. Then I think that concludes my demo. If you have some questions, I can take it.
Sir,
Right.
touch upon that.
So basically, for at least for 1.9, I was facing issues with the Weave and Calico. At least for the Vagrant environments, the CNI was always going into crash loop back off. So Weave usually you don't need to specify the pod CIDR while doing a QADM in it, but looks like if you specify it, it is able to run. But I don't think that is mandatory. So this needs to be checked on why Weave, which was earlier working without specifying that parameter, is now not working. So this could be related to some new CNI changes also, because from 1.9 of Kubernetes, you are supposed to use the CNI version of 0.6.0. We did not face any issues when we were using 0.5.1. And one more issue that I noticed specifically for CentOS is when using kubeadium, when you restart your VMs, the Kube API server does not start. So one of the reasons was you had to specifically, your etcd was not starting because it did not have a listen peer URLs parameter to it. So before you reboot the machine, you'll have to update your etcd manifest in Kubernetes manifest files to include that, and your cluster should come up just fine. And I just saw one of the users asking the same question today on kubeadium user channel.
Yeah, I think that's particularly helpful, Uday, the issue that you just mentioned,
right,
with respect to the etcd.
Just one question occurs here.
Yeah.
Where do you download this etcd YAML files? Actually, I didn't find in Vagrant files. I have to set up a multi-master setup in bare metal.
Okay.
So I made some changes in Vagrant files for multi-master setup, but I didn't find etcd and other components. So where do you download it?
Specifically, whatever manifest that I am talking about, that kubeadium generates them for you, and it will put it under etc/kubernetes/manifest.
Okay.
Okay. Uday, I have got one question around alpha and the beta features that Kubernetes exposes around its releases.
Right.
Do we have a facility where I can enable, disable, or toggle those features before I do a Vagrant up?
Okay.
Those are typically the gate stuff. We have to specifically enable the gates,
right,
to have those features.
Currently, the box does not do that, so it will just bring up the cluster with the default features enabled. So if you want some specific feature gates to be enabled, you'll have to apply to Kube API server and restart the pod. Or, I mean, going forward, maybe we can add an option where you specify what feature gates or something that you want to be enabled. And I mean, we have to pass it to QBDM unit, and I think there is a way to do it. We'll just have to explore.
Yeah, all right, fine. Even the manual steps are also fine with me.
Yeah.
I just need to know the steps, so what to do to enable the gates.
But one thing that I've noticed with QBDM is it may not support all the feature gates that Kubernetes is providing. It may only support a few.
Mm-hmm.
So
yeah, fine. I'm even ready to get into the the launch scripts of, let's say, the kube scheduler and all those things to get the feature.
Right. Anything else, guys? Okay, then. Thank you, everyone.
Thank you, Uday.